Here in homework 11, we are looking at how to find the inverse CDF so that we can plot random numbers according to a formula that is already known. So as a simple example, here we have the exponential distribution, which we can see f of x equaling lambda and e to the negative lambda x. So that is the first step in the process. We're determining the formula and then we're determining the support. So in this case we'll be integrating from 0 to infinity. We'll be using that x variable to preserve the independent variable in the formula, and when we do that we come out with the formula here. We'll be calling it g of x equaling 1 minus e to the negative lambda x. Then once we have this, we'll be solving for the inverse, so we'll have to take the natural logarithm to take this e part out of it, and what we end up with is the inverse of g to the x is the natural logarithm of 1 minus r, which will be a random number distribution, multiplied by negative 1 over lambda. And then we'll just be generating random numbers using those into the equation, and we'll be developing histograms which have exact or very close to simulation of what the original equation looks like. So looking at that in MATLAB, here we have a simple uniform random distribution, and when we run this we can see that for the most part it is very even on our distance from 5 to 25, and we can say that for the sample it's pretty clear that it follows that distribution according to the initial formula, which simply is a flat line. In another example, here we have x minus 2 divided by 8 as the initial formula, and we solved for that inverse CDF. We can see of similar slope in the histogram is the chart, and also looking at a third one involving an exponential function. As we discussed in the example, we can see the decline of the frequency as it's going down, as well as the simulation in the chart. And lastly, we'll just look at a piecewise function. Here we can see that from 0 to 0.9 we have a function that defines part of it, a piece of that function, and a right side border of 1. And when we run this, we can see from the initial function that it's going up in slope, and the triangular distribution ends down at 1. And from our chart right here, we can see that similar simulation going on when the numbers are randomly generated using that inverse CDF. Thanks for watching.